Hi guys. Okay. Hey, how was the probability homework?
Pretty easy.
It was a little concerning to me the way you guys have done. How was it?
I couldn't do it because I didn't have time to do it.
But not doing the homework is not going to help, right?
Yeah, I'm gonna try to finish it this week.
How about you, Ishan?
I didn't see it.
You did not see it? Did I not give? Johan, did you see the homework? Johan? Okay, he's not here. Wait, I really want to see because this was really concerning to me. Okay, how did you find Sri Hari and Devansh? How did you find?
It was pretty easy and straightforward.
Yeah, it
Pretty
was
easy.
straightforward.
Okay, but I did not see. What are you doing in school, Devansh?
The periodic, no, the periodic theorem. The
What is it?
the one theorem for the right triangles. The
Pythagorean
period.
theorem? Okay.
Yeah, that one.
Shrestha, I didn't see your homework, right, Ma? You were busy.
Yeah.
Okay. I'm a little concerned, guys. Okay. Inian, you did not?
I did it, Auntie. I just never sent it.
Did you submit it in the classroom?
Oh, not yet.
Okay, I'm a little concerned, guys. Okay, anyway, let's see. Let's see. I have some. Let's see. Let's see. I'm going to go over one more time, but I'm a little concerned for sure. Uh, Nikita, are you here? Oh my god. Okay, she's also not joining. Wait, guys, there's a lot of the Okay, Nikita is not in here. Okay, let's go ahead and do a few review problems. Then we'll see where we are. Okay, how about this one? Shruti, what are you doing in school, ma?
We're doing the circumference and area of circles.
Is that easier?
Yeah.
And Arya Sricharan, what are you doing in school?
Same thing. Circumference and area of circles.
Do you want me to review that a little bit or can I go ahead with probability? What do you guys think? Pranav, what are you doing in school? And Johan?
Pythagorean theorem.
Okay, Johan?
We're doing inequalities.
Oh, inequalities. Okay. Johan, is that easier at school now?
Yeah, well, easy.
Okay. Sorry, Arya Sricharan, what did you say? I forgot, Amma.
Circumference and area of circles.
Okay, we have already covered that. You are more than welcome to look at an older assignment and do Arya Sricharan. Does that sound like a plan?
Yeah.
Okay. I just want to continue with probability. So let's go ahead and see. Okay. So let me have a quick review of whatever I gave you. Let's see. Okay. Last week we did start with probability, right? Maybe there were a few tough questions as well. So let's see. How about this? Okay, this one you can just see an answer, I feel, guys. So let's review that a little bit and then I'll go through more probability. Okay, so let's see here. How about this? How about this? I really want you, a spinner is shown on the right for which each outcome is not equally likely. If you spin the spinner once, what is the probability it will stop at A? Please answer in chat, guys. I really want to see where we are and then proceed with wherever we are. That's fine. Go ahead, guys. It's an easy one, right? See, okay, this is what I want you guys to do. Let me see.
No, teacher,
Yama,
it's not letting me chat.
it's not letting me chat with you.
Yeah, same.
What does it say, ma? Meaning, see, this is something I am having trouble with. What does it say?
Oh, so when I try to type, there's like at the top of my screen it says you cannot chat with meeting group. Chat during this meeting.
Yeah, don't chat in the general one, right? But you can always chat with me in a single chat, right?
Yeah. So I put new chat. I clicked on your name. And yeah, I'm chatting with you. And this is a public chat too, which is disabled.
Not really. Hold on. Okay. Let we are taking a lot of time.
Mm.
1 second, guys. Sorry, guys, there was something here. Okay, so did you? Okay, I'm going to get you to chat, Amma. Wait, let's see what is going on, guys. Srihari, you can chat with me still. Do you see it? See, reply to my message. Then what do you want? Who's not able to chat? Krishiv.
Me.
Yeah, you can chat with me. See, you can reply to my chat, right?
Oh yeah.
I'm not sure, guys. There is a
Oh,
new
yeah,
chat, but there's a private chat that you can do with me. Arya Sri Charan. Did you answer this question? Good job, Krishiv.
Yeah, I'm typing.
Uh-huh. Devansh. I'm waiting for your answer. I just want to know the answer for E.
Oh,
Arya Sri Charan, did you look at the homework?
No,
Why, ma?
I don't have time.
Okay, but you know the Google Classroom, right?
Yeah.
Okay. Devansh, that's correct. Good job. Srihari, that's correct. Whoever did the homework, you're able to answer. This is good, Ishan. Sreshta, why is it 2 by 3, ma?
Because would it be half instead?
Yeah.
Okay.
Correct one. Correct. Can you do that?
What, half?
Okay. Yeah, half.
Okay.
Okay. My problem I'm seeing is several of you are not doing the homework. If you come back, it's definitely not okay, guys, because you're all pulling the class down. This is never going to work with me. Okay, next week if I don't see the homework submitted, it's not going to work. You can come back after looking at the recording and doing the homework. Okay, so I will pull you out of the classroom. If you're not going to do the homework, it's not going to work. Okay, so clearly whoever has done the homework is able to answer. Whoever has not, you're not able to answer. And there's no point going back, right? We all learned probability last week. Now I'm having big trouble getting you up to speed and running. So that's not going to work. Okay, let's see. How about this? Okay. I just want to see whether you remember what is sample space. How about this? Justin bought a package of pens that contained one black, one blue, one red pen. He randomly pulled two pens out of the package. Okay, now what's the question for you is use a list to represent Justin's sample space for selecting two pens at random from the package. Let me know, guys. If you don't know, I have to see that you don't know.
Do we write the list in the chat and send it to you?
Yes.
Okay.
So we're just writing all the possible outcomes.
I got 3 answers. Good job, guys. I want the sample space, Johan. Johan, did you do the homework?
I did.
Did you submit it?
No, I think I forgot.
You did the homework, but where is the sample space, I'm asking?
Yeah, I think I might have forgot to submit it.
Oh, okay. But can you send me the sample space?
Yeah, okay.
Srihari, that's right. Arya Sricharan, that's incorrect. Devansh. Okay, nice. Okay, so you're all telling me the size of the sample space, which is still good, guys. I'm happy. Krishiv, good job. Okay, but Srihari, when you sent your answer, right? Let's see. One red, blue. How come Srihari? See here. Okay, Shruti, do you know the answer for that?
I kind of forgot about the sample spaces.
Okay. So you have a package of pen. You have a package of pen. This is the package. It contains one black, one blue, one red pen. Now, if I want to pull two at a time, what are the possibilities, guys? First, I'll pull black. Yeah, go ahead. I can pull black, blue or red for the first, right? Second time when I pull, after pulling black, it can be what?
Red or blue.
Yeah. Or after pulling blue, it can be
Red.
black or red. After pulling red, it can be black or blue. So see here, RB, but this has to be blue black, right? Blue black, then black blue, again it's the same thing. Black red, then what? RB is here and RBL is already RBL, okay, is already here. So There's only 3 sets of 2 in the sample space. Did you get it? Sri Hari, B and BL is the same as B and BL, right?
Oh, yeah.
So samples, suppose if I throw a die, right? See guys, we keep revising what we did last week, which I really don't want to. Suppose there is a fair-sided die and I throw it. What is the sample space? All possible outcomes. So 1, 2, 3, 4, 5, 6. That is the sample space, correct? Now, coming to a spinner. Let's say it has regions 1, 2, 3, 4 equally likely. What is the sample space? 1, 2, 3, 4. Now, I toss a coin twice. What is the sample space? First I can throw a tail or a head. Then I have to draw the tree. First throw can be a tail or a head. Second throw can be, after throwing a tail, it can be a head or a tail. After throwing a head, it can be a head or a tail. So what are the sample space? What are the possibilities? Tail head, tail tail, head head, head tail. So always you enclose the sample space in curly braces. Any questions? Any questions? We are repeating exactly what we did last week. Can I move on? Okay.
Priya?
Yama?
The homework was posted late, so I'm halfway done.
Okay. Did someone ask? I would have gone and seen. Did you ask? Did I miss it, Ma?
No, it was just posted late.
Yeah, why don't you ask, right, when you discovered that there was no homework at least?
I thought you were just gonna assign the test like you said last week.
Ah, okay, Ma. Taken. I got it. Okay, you know what? But I did give you time as well till 17. But my thought is when you come for the class, right, if you are not sure of what we discussed last class, right, it pulls the entire class down. You see what I mean? Meaning, if you had gone through it, at least you would have known what is inside. You see, that's what it is. Okay, absolutely okay. I understand, Ma. Good thoughts. Now let me go ahead and ask more. Okay, how about this? Okay, how about this? I just want the sample space for this one. As long as you're able to remember what was dealt with, Mar Shrestha, I don't have a problem at all. I have messaged the details to your mom as well. Don't worry at all. In your case, you're able to answer. So, absolutely, I don't have a problem there. Okay, guys. Here, Mary is conducting an experiment in class. She wants to determine the probability of getting. Hey, Nikita, you missed last class, right, Ma? Would you mind going through the recording, Ma?
Yeah, I'm sorry.
No
I
problem.
didn't
Your
know that
dad
class
just
has
messaged
started.
me. Yeah, dad just messaged me. So Mary is conducting an experiment in class. She wants to determine the probability of getting 3 heads. See, one thing is sample space tells you what are the possible outcomes. Let's define that. Sample space tells you all possible outcomes. All possible outcomes. Now, suppose size of sample space. What is the size of sample space? The number of possible outcomes. the number of possible outcomes. This is what we discussed last week. Now guys, if you are asked about the probability, this also we did discuss last week. That is defined as 1 minute ma Devansh, I saw your hand. Number of favorable outcomes divided by the total number of outcomes. Number of total outcomes. Any questions guys in this?
Wait, are we doing the probability for that one?
Let's see. Let's see the question. Suppose if you have a die, fair-sided 6-face die, the sample space is 1, 2, 3, 4, 5, 6. Size of the sample space is 6. Probability of getting an even number is 3 out of 6. 3 favorable outcomes. Probability of getting an even number. This is how you denote. Probability of what comes inside the parenthesis. Okay, the favorable event, right, comes inside the parenthesis. That is an even number, is 3 by 6 or 1 by 2. Yes, Devansh, what was your question?
Say the size of all the possible outcomes.
What, ma?
I was going to say all the outcomes that are possible.
Oh, yeah. So, here, she wants to determine the probability of getting 3 heads. Okay. Now, let's do this. This is a complex question because she is going to throw a penny, nickel and a dime. Right? 3 things she is going to do. But any order doesn't matter. Penny, nickel, dime she is going to do. Now, when she throws the penny, please draw the tree. When she throws the penny for the first time, she can get a head or a tail. Now, when she throws the nickel, the first can be a head, but the nickel can end up with a head or a tail. Again, first time when she throws the penny, she could have gotten a tail. But when she threw the nickel, right, again she can get a head or a tail. Now guys, with the penny, she could have gotten a head and a head. But with a dime, she can still have a head or a tail. So it becomes complex, right? See here. Now, represent the sample space of her experiment. How do you represent the sample space of this experiment? H is one possibility. I'm going to write it down, okay? Then HHT is another possibility. Then HTH is another possibility. HTT is another possibility. Then THH is a possibility. THT. Jashwita, are you following, ma? Then TTH.
Yes.
TTT. This many possibilities are there and this is called the sample space. Size of the sample space is 1, 2, 3, 4, 5, 6, 7, 8. Nikita, are you with me, ma?
Wait.
Yeah.
So is my first answer
question.
wrong?
Yeah, Krishav, go ahead.
Is my first answer wrong? Where I put like 2 heads and 1 tail?
Is your first answer wrong? Let me quickly check. So I was not looking at the answers because I was explaining. 1 minute, ma.
I corrected my answer by putting 8.
You put 8. 8 is correct, ma. But 2 head, 1 tail. But you should have 8 in your sample space as well, right? You see what I mean?
I thought it would be like 1 tail and 2 heads would be the same as 1 head, 1 tail, 1 head.
Wait. But these are all different, right?
Yeah.
What did you think?
I thought...
Okay. Yeah. Wait. So you thought this and this are the same,
Yeah.
Okay, wait. What is given? Yeah, we need to see. Wait, ma. Sample space of our experiment by either using a list or a tree diagram. She wants to determine the probability of getting 3 heads when flipping 3 coins. Okay. So, okay. Krishav, your question is right though. Meaning you're thinking head, tail and tail, head are one and the same, you're saying, right?
Yeah.
Yeah, nice question. But in this case, you're throwing Let's see. 1 second, guys. In this case, see, the problem is you're throwing penny, nickel and a dime, right? Getting a head on the penny is different from getting a head on the nickel is different from getting a head on the dime, isn't it? What do you think?
Yeah.
Am I making sense?
Yes.
I know, meaning, I know, very good question, Krishiv, though, very smart question. So I understand he's saying, hey, two heads and a tail, they both are one and the same, right? Why can't I have them the same? But see, penny, getting a head on the penny is different from getting a head on the nickel. You see, even if it is HHT, this meant penny is getting a head, nickel, dime. Here it was penny, nickel, dime. So that was a little different. You see, it's a little different. So in this case, 8 different options are there. Does that make sense, Krishiv? Krishiv, did it make sense to you?
Yes.
Okay, good. Okay, that's nice, but good question. Cleared it for all as well. Okay. Now, I want one of you to draw the tree diagram on the board. Okay. What is the possible sample space? What is the sample space for this? He's having pizza party for his birthday and is offering several choices to his friends to order individual pizzas. Each pizza will come with cheese. Okay, each pizza will come with cheese, a choice of either thin, original or stuffed crust, and a choice of either vegetarian or pepperoni. You see, each pizza will come with cheese. Okay, then a choice of either thin, original or stuffed crust. How many crusts are there? 3 crusts are there. And then you have the choice of either vegetarian or pepperoni. Now tell me, what is the size of the sample space first? What is the size of the sample space?
5 or 6.
Yeah, why don't you draw in your notebook? Send the answer to me.
All the size is just all the probabilities, right?
Correct. All the possible outcomes. Srihari, we are not talking about, are we talking about probability here? I thought we are just completing the sample space. See, we are only talking about possible outcomes. We are not talking about probability, which is always a fraction.
Well,
See what I mean?
that was my answer to the last question.
Oh, sorry. Okay. So only when I ask for probability, fractions come into picture. I'll talk about it now.
Ma'am,
Yama?
is my answer right?
Ishan, 1, 2, 3. Yep. Ishan, that seems right to me. Krishiv, that seems right to me. Arya Sricharan, I'm waiting for your answer. Devansh, that's correct. Johan, that's correct. Sreshta, really ma? How did the sample space become 10 ma? Jashwita, correct. Pranav,
Wait, Miss Priya, wait.
nice Pranav. I really like the way you have given. Tell me ma, Sreshta, how did you get that?
10?
No, yeah, how did you get the 10?
I took 1 and then I split it into thin, original, and stuffed, so that made 4.
Let's see ma. Cheese pizza, okay? Cheese pizza can be what? Can have thin, original
Oh,
stuff.
I see where I went wrong.
You got it?
Yeah.
Okay, and then each of this can have what? Vegetarian or pepperoni. So basically, see, one easy way to get the sample space, right? See, this is 1 times 3 times 2. You get it? It's always the multiplied factor. Okay, that's the secret that I didn't want to tell you. I wanted you to figure out what I told you. Okay.
Miss Priya, I did
Yeah, go ahead.
it differently.
What was that? Tell me.
I wrote vegetarian and pepperoni on the side, then wrote the for VT, VO and VS, and did the same thing with the pepperoni. And I got 6 with that.
In this case, it will work, ma.
Okay.
Okay, does not matter. But in some cases, if you go in the reverse, it may not work.
Miss Priya,
Yeah, ma?
can you explain how to do the last question?
Okay. No. You're given a cheese pizza, right?
Yeah.
Then you can have thin stuffed or thick crust, whatever it is.
Mm-hmm.
And then with these, each of this can be pepperoni or vegetarian.
Vegetarian.
Pepperoni, vegetarian. You got it?
Mm-hmm.
So how many does it make? 1, 2, 3, 4, 5, 6.
Yeah.
Cheese pizza, thin crust, pepperoni. Cheese pizza, thin crust, vegetarian. Cheese pizza, stuffed crust, pepperoni. Cheese pizza, stuffed crust, vegetarian. Cheese pizza, thick crust, vegetarian. Cheese pizza, thick crust, pepperoni. Make sense?
Yeah.
So this is called the sample space. You're telling all the possible outcomes, right? Now let's say there is a die, okay? Okay, this is a fair 6-phase die. Fair 6-phase die means all are equally likely. Okay. Now, here probability of getting an even number, as I told you, right, was 1 by 2. Why 1 by 2? This is the number of favorable outcomes divided by the number of possible outcomes, right? Now, what is the possibility of getting a 3? What is the possibility of getting a 3?
Miss
1/6.
6th.
Miss Priya, instead of writing a fraction, can you write a percentage?
Okay, good. Very nice question. You can write it as a fraction. You can write it as a decimal. You can write it as a percent. Okay. Usually when they ask for probability, if nothing is mentioned, you mention it as a fraction. Okay. Sometimes they'll say, hey, express it as percentage. Now, probability of getting a 3 is 1 out of 6. Now tell me guys, what is the probability of not getting a 3?
Out of 6.
5 out of 6.
So do you see, meaning probability of an event and probability of not of the event sums up to always
The total.
What is the total?
The total sample space.
We are not there. No.
It's to 1.
Huh?
It's something to 1.
Correct. What was
Like
that?
it can be anything.
Like the
No, it can't be anything.
probability of event and probability of not event, it sums up to 1.
It sums up to 1. So the max, if they ask for probability as a sanity check, when you look at the answer, your answer has to be less than 1. You see? The maximum probability of all, see, what is the probability of, let's say, 5. No, I don't want 5. Okay, 4 or 5. It's 2 out of 6, right? What is the probability of not 4 or 5? I don't want 4 or 5. What is the probability of that? Will be 4 out of 6. You see? So it always sums to 1. What always sums to 1? This is probability of an event, right? Probability of not of the event, that is called complementary probability. Probability of not of an event is called complementary probability. The sum of the probability and the complement events probability always sums up to 1. So, when you're asked for a question, right, if it is 1 by 6, if you express it as a percentage, it's easy. Fraction to a percentage is easy. That's why I'm saying, if the probability turns out to be 1, for sure the event is going to happen, and that's 100%. Because 100 by 100 is 100%, right? Do you get it, guys? Yes, Jashvita, do you have a question? Yes, Jashvita.
I don't get the fraction part.
What fraction part? Where, ma?
When like p by 3 equals to like 1 by
probability of an event. Okay, so probability of getting 4 or 5 is 2 by 6. Probability of not getting a 4 or 5 is, then you need to have 1, 2, 3 and 6. So 4 out of 6. You got it?
Okay. Kind of.
Can I go to the bathroom?
Yeah, ma. What is that kind of, Jashvita? Where are you not getting? I'll help you again. So see, ma, I have a coin. Okay. Probability of getting a tail is what?
1 by 2.
Okay. Probability of not getting a tail is what?
2 by 1.
What? No. Probability of not getting a tail when you flip a coin. Okay. Probability of not getting a tail, what is the favorable outcome you would expect? You don't want a tail. So what is the favorable outcome? When you flip a coin, you don't want a tail. Then what is the favorable outcome?
1 by 1.
Jashvita, answer my question. We are talking about probability of not getting a tail. When you flip a coin, what are the favorable events not getting a tail? Then what you should get? I don't want a tail. So what are the other possible outcomes?
Heads.
Head. So 1 out of how many possible outcomes are there when you flip a coin?
2.
2. You get it? So see, probability of a tail, probability of not a tail, always the probability and its complementary probability sums up to 1.
Okay.
Make sense?
Yeah.
Okay, let's see this one. I'll explain one more time. Spinner. I have a spinner. Now, probability of getting a 1 in the spinner is 1 by 3. Right? Probability of not getting a 1. What are the favorable events for not getting a 1? It can either be a 2 or a 3. So favorable events are 2 out of the total 3. When you think about the probability of 1 and not 1, the probability sums up to 1. Nikita, am I with you?
Yeah.
Let's see. Okay. Now, probability can have simulations. I don't want to go to simulations, but I can discuss. Okay. Suppose simulations means I can simulate the probability, meaning an experiment, right? Let me show you. Meaning, let me give you examples.
Can I go to the restroom, Miss Priya?
Yeah, ma. Okay, let me give you examples of wait. Let's see. I'll start with smaller ones. You know the term simulations, guys? Do you know what is simulation?
No.
Simulate an experiment means you are going to simulate not a real version, okay, but some. Let's see, I'll give you one example maybe. Okay, okay, let's see this one. Okay, how about this? How about this? You tell me, this is just a revision of what we did. First, you tell me the answer to this. Now, let me write it down for you. I have the word balloon. I have the word balloon. You're picking out a letter from this word balloon. You're picking out a letter from this word balloon. Okay. What is the probability that it is a L? What is the probability that it is a L?
Do we answer in chat?
Yes, ma.
Is my answer correct?
I'll come there, ma.
Miss Priya,
Yeah, ma.
for me it says you cannot chat with meeting group chat during this meeting.
You have. Okay. So basically, okay. Nikita, for you, is it for you, Nikita?
Yeah.
Okay, I'll help you, ma. No, you have to open a private chat, ma. That's all. There is a new chat button, right?
Yeah, I did do that, but I put the answer.
Okay, can you
Yeah,
answer?
it said I see hi, but when I'm trying to send it, it's saying you cannot chat with meeting group chat during this time, during this meeting.
Okay, you're not able to input. Are you using web or app, ma?
App.
Okay, I don't know. You have to shout out the answer for today. Tomorrow, maybe next week, I'll enable. I don't know what to do. Actually, this has been a problem. I think it's a problem with Zoom itself. We'll see, ma. We'll see. I'll try to
Okay.
enable the group chat. Okay.
All right.
Yeah. So coming to the word simulation, what guys? It's just a real world experiment is there. Okay. I'm trying to make a bogus version of the real world experiment. Does that make sense? Meaning, let's say I know of a real world process. Okay, for that process, if I want to find out probabilities, right, I will simulate it using a die. I'll simulate it using a coin. Okay, let's say, how about this? Suppose the event of, let's say, in a family there are two kids. What is the probability that both are girls? I want to find out. This is a real world process, right? Real world. In the real world, in a family, there can be two children. In that two children, both can be girls or both can be boys and a boy and a girl. It can be anything. So I want to know the probability of two girls. So how can I simulate it? The real simulation for this example is flipping a coin. Coin toss also has two outcomes, head and a tail, right? So one I can have it as a boy, one I can have it as a girl, correct? When I flip a coin, it can either be a boy or a girl. So for the real world process of understanding the probability of two girls in a family, I can run an experiment by tossing a coin, because the number of outcomes there is 2, number of outcomes here is 2. Boy and a girl, I can match it up with the head and the tail. So this is called simulating the real world process. So conducting an experiment or simulating a real world process is what I do. Okay, to find out probabilities. Okay, that's an important part when we are learning this. Okay, did you all send the answer for okay, that's good. Pranav, that's good. Shrestha, that's good. Johan, that's good. Arya Sri Charan, that's good. Pranav, that's good. Ishan, correct. Devansh, did you get it? Srihari, how did you get 1/7? There are two O's, right?
What?
There are
Oh,
two O's, right?
yeah.
Then how did you get 1/7?
Oh, I thought it was the probability of L.
I asked you the probability of getting L is 2 out of the total, right?
Oh, yeah, there's the L.
Did you get it, ma?
Yeah.
Okay. Okay. Now let's go ahead and do this one. I'll erase this off. I'm going to introduce you to experimental and theoretical probability. Okay. experimental versus theoretical. This is a very important concept in probability. Okay, we'll go to simulations once more. Okay, for now let's study this experimental and theoretical probability. Okay, what is this? Okay, guys, I have a die, a fair 6-sided die. Okay, what is the probability of getting 1 by 6? What is the probability of getting 2 1 by 6? What is the probability? The sample space is 1 2 3 4 5 6. What is the probability of getting a prime number? Prime number is 3 out of 6, which is 1 by 2. So whatever I discuss here based on the knowledge I have, I'm discussing this based on the knowledge I have and assuming that this is a fair-sided die where each face is equally likely to turn up. If I think about it like this and come up with probabilities, that is called theoretical probability. Does it make sense? In theory, we understand all this is true. Suppose I have the same die. Okay, I start rolling the die. Okay, one time I roll. Okay, let me say the first time I roll, I got a 1. Second time I roll, I got a 1. Third time I roll, I got a 3. Fourth time I roll, I got a 1. Fifth time I roll, I got a 6. Okay, now sixth time I roll, I got a 1. Seventh time I roll, I got a 4. Now guys, eighth time I rolled, okay, I got a 2. Now I know I did an experiment here. I performed an experiment here, right? Performed an experiment of rolling a die. Okay, the same fair-sided 6 die, meaning a fair 6-sided die I rolled. But then let's see what happened to the probabilities. Number I got 1, 1, 1, 1. 4 times I got out of 8. Probability of 1 was 4 out of 8. Probability of 2 was 0. Probability of 3 was what? 1 out of 6. Probability of the number 4 was what? Again 1 out of 6. Oh, probability of 2 was 1 out of 6. I didn't see that. Okay. Probability of 3 was 1 out of 6. Probability of 4 was 1 out of 6. Probability of the number 5 was absolutely 0. Probability of 6 was what? 1 out of 6. Now let's compare both. You did an experiment. Then you tabulated the values. From there, you calculated your probability based on the results you got. Correct? 8 times you performed the experiment and you calculated the probability of 1, 2, 3, 4, 5, 6. You got, for 1, see here, the theoretical probability of was 1 by 6. But the experimental probability was 1 by 2. The theoretical probability of getting a 2 was 1 by 6, here as well 1 by 6. Probability of getting 3 was 1 by 6, 4 by 6, the 4 was 1 by 6. So those all were the same. But there are some for which the theoretical probability did not match the experimental probability. Did you see it? So whenever we discuss probability, the theoretical probability is your ideal scenario where you should be getting it. But when you perform the experiment, only when the number of tries is like 1000, 2000 times when you roll the die, the experimental probability will try to match with theoretical probability. Now, what is this experimental probability? You are performing an experiment and tabulating what outcomes you get. And based on that table, you calculate your probability. That is experimental probability. Got it, guys?
Yeah.
Okay. Now, let's say I have a spinner. Equal, fair, 4-sided spinner. What is the probability of getting an odd number?
2 out of 4.
2 out of 4. This is theoretical probability. Now, I am performing an experiment. Okay. I am spinning the spinner so many times. Okay. Okay, these are the so many times you are going to calculate the probability. Okay, first time, second time, third time, fourth time, fifth time, sixth time, whatever I get, I am going to give it to you. Okay, what did I get? 4, 4, 4, 4, 2, 1.
Miss
Now,
Priya, isn't
Yama,
it a 1 out of 4 to get a odd number?
1 out of 4 to get an odd number. Odd number is 1 and 3, right?
Is 1 an odd number?
1 is an odd number, right?
Oh.
Why? 1 is not a prime number, but 1 is an odd number, right?
Oh.
That's where you got confused.
Yeah.
That's okay.
Priya,
Yeah, so now the
can't see
trial
how
number, this is the trial number, this is the outcome you got. Okay, now tell me what is the probability of getting an odd number? What is your experimental probability of getting an odd number? Who can answer? What is the experimental probability of getting an odd number?
Miss Priya,
Yeah.
what were 5 and 6 again?
I didn't get it. I did only 6 trials. This is what I got. I never got my spinner. See, I keep on spinning.
Well, I'm saying for like trial 5 and 6, what number?
Oh, you're not able to see 2 and 1, ma?
Okay. It's still, it's like blank there.
That's covered up for me too.
Yeah.
If it's just 1. No, except it's 2 now.
Okay, guys, let me do it again. Thank you for telling. Trial, outcome. Is this okay, ma?
Yeah.
So how many times I tried? I performed. I spun the spinner first time. I got a 4. Spun the spinner second time. I got a 4. I spun the spinner third time. I got a 4. I spun the spinner fourth time. I got a 4. I spun the spinner fifth time. I got a 2. I spun the spinner sixth time. I got a 1. What is the experimental probability of getting the odd number?
1 out of 6.
1 out of 6. What is the experimental probability of getting an even number?
5 out of 6.
5 out of 6. Do you see, guys, there's a huge difference. Whereas my theoretical probability, see, of getting an even number is what?
The even number is
4.
2 out of 4. That's 1 by 2, right? See, they're not same at all. So theoretical probability is very different from experimental probability. Why? It really depends on the number of trials I do. If the number of trials of the experiment is like 1,000, 2,000, 10,000, then automatically your experimental probability will merge with your theoretical probability. Make sense?
Miss Priya, most of the questions we'll get will be theoretical, right?
Most of the with respect to your EOC, you will get a question on experimental probability. By default, every year you're getting an experimental probability.
But will they like give us the chart?
Yeah, they will give you the chart. Yes.
Okay.
Okay, so let's try this one. Okay, this one here is an experimental probability question. Let's see. We will do it slowly, okay, but we'll understand and do. Mario has a jar that contains 2 blue marbles, 1 red marble. I'm going to draw, okay? Any question is better to draw. She has a jar with 2 blue marbles, 1 red marble, 3 green marbles. Okay, he drew 1 marble from the jar. Okay, did not replace and then drew another marble from the jar. Okay. So, see how many trials did he do? 10 trials, right? You don't need to calculate any theoretical probability here. Okay, he did only 10 times. What are they asking? Mario repeats this experiment 180 times. What is a reasonable prediction for Mario will draw 2 blue marbles? What do you all think, guys? I'll wait. First of all, he did the experiment 10 times. Okay, they are only asking for experimental probability. Okay, they are not asking about theoretical probability at all. What is the probability that he is going to get 2 blue marbles? Let me underline. Out of the 10 times he did, right? How many blues are there? This is a blue. Then what? Here there is a blue. Then there is a blue. What do you all think of the experimental probability of out of 10 trials?
3 out of 10.
3 out of 10. Good job. That's true. 3 out of 10. But the question is not really that. What are they asking?
If Mario rolls it 180 times, what would
Exactly.
be
If she rolls it 180 times, how to calculate that? What do you think?
3 times 8,
3 by 10?
3 times
18.
10 times 18 equals 180, and then so 3 times
3
18.
times 8.
Yeah.
So what is the answer?
54.
Over 10.
54. Good job. Who said that? How did you get that?
So I knew that 10 times 18 would be 180.
3 blue out of 10 trials, right? Yeah.
And
Now
then
if we repeat,
10 times 18 would be 180. So 3 times 18 would be 54, and that would be 54 over 10.
Good. So you found out the probability in this 10 trials, right? 3 out of every 10 had a blue. So you know the experimental probability of getting a blue, right? Now if he repeats that 180 times, multiply that by 180, you get your answer. So you can expect to have blue 54 times out of the 180 times he did. Does that make sense?
Miss Priya,
Yeah, go ahead.
half the things you write I can't see.
Yeah, below
on the bottom.
No problem. I wrote it here, ma. I didn't write anything beyond that down. So I just wrote this down again. That will be equal to 54. Make sense?
Yeah.
Okay, now if I stop and reshare, you'll be able to see everything.
Wait, Miss Priya, can I go to the bathroom?
Yeah, ma, sure. See, now you should be able to see. Let's see. How about this? Blue. 3 out of 10, right? That's your experimental probability based on the chart given. But then you're repeating it 180 times means then you will know when you multiply it by 180, you will understand how many of the 180 times you'll get a blue. Did you guys get it, guys? So, what did we discuss today? Only theoretical versus experimental probability we discussed. Okay. Now, let me move on a little bit more. Okay. So, you're going to work on these. Okay. Coming to the simulations, right? Let's try these out, guys. I want you to understand. Let's see. Okay. We are going to discuss one problem on simulations. Simulations means you are going to practically do the same real world process as an experiment. A fast food restaurant, see, that is a real world example. A fast food restaurant plans to randomly include one of the 4 different toys in each children's meal they sell. Okay, they're selling children's meal. In the children's meal, they want to include one of the 4 toys they have. Which of the simulations could be used to determine the random toy that will be included in the first 100 children's meal? In the first 100 children's meal, they want to understand, they want to really identify which simulation they can use. Okay, for what? The scenario is they have 4 different toys. So the sample space has 4 outcomes, 4 different toys. They have to pick one of the 4 for each kid. Okay, now what do you think? Read through each of these scenarios, each of these experiments, and which of these experiments mirrors the real world scenario of the fast food restaurant picking one toy out of the 4 toys they have for the first 100 children? Do you think you can flip a coin 100 times? The number of times they have to do this experiment is 100 because they have to pick a toy for 100 times. Then only they can predict for 100 children.
That you can't do a coin because it's only 2 outcomes.
Exactly. The number of outcomes is going to change. So definitely you cannot be flipping a coin. Roll a fair 6-sided number. Do you think that can be done?
No, because there's 4 toys, not 6 toys.
Exactly. There are 4 toy 1, toy 2, toy 3, toy 4 are the 4 different options. And then the experiment should mirror the scenario where I pick 1 out of 4 and repeat it 100 times. So which one will be good?
Are we supposed to tell it in the chat?
No, why don't we discuss, Amma?
The last one.
Which one, Ma?
The last one.
Last one. Place 4 different playing cards face down. Okay, let me place it face down. What happens? Randomly draw a card. This is toy 1, toy 2, right, Ma? There are 4 possibilities. You're picking one of that. And then you repeat the picking 100 times. Yes, it's exactly similar. This is one of the simulation. Good job.
What about the second one?
Use a spinner. Oh yeah, that's correct. A spinner which has 4 different equally likely outcomes. Equally likely means each can occur the same number of times. Oh yeah, because 1, 2, 3, 4 can really mirror toy 1, toy 2, toy 3, toy 4. You're going to spin the spinner 100 times, will mirror 100 children. Good. Why can't this be the answer? Write the numbers 1 to 100 on a piece of paper and...
It's 1 to 100 when there's only 4 toys.
You only need 4.
Exactly.
There's 100.
Now you understand how to pick a simulation for the real life process?
Yeah.
The number of sample space should be same, and how many times you're repeating the experiment should both match. Okay, guys. So I'll stop here. I'll let Shruti go. I'll stop here, but your homework will be a little bit of a challenge. Number of problems will be less, but it is going to be a little bit of a challenge. In the sense, you're going to sincerely work on the problems and come back. Okay. Right away, I'll post the homework, Ma. Okay, Sreshta?
Okay.
Okay. Any questions for me?
Bye.
Bye, guys.
Bye, Miss Priya.
Miss Priya, I was just wondering what we learned last class.
Last class, okay. So,
I can look at the recording, but I'm just wondering.
Yeah, same probability.
Okay.
Didn't miss much.
All right.
Didn't miss much at all. Okay. Many of them did not remember sample space and stuff. I repeated so many times. And you know what? There is one assignment that you can sit and do and see. That is different. That will help you a lot to understand more on probability.
Okay.
Makes sense? But please do, Ma. What are you doing in school, Ma?
We are currently learning about Pythagoras theorem, and we're doing like a project about the Pythagoras spiral,
but that is
it's easy, yeah.
Okay. Wait, Ma. I have okay. Can you tell me your dad's email? Can I send this to him quick?
Yeah, Vikram.
1 minute, Ma. Let me say welcome G78. Session 3, yes. 1 minute, Vikram. I'm going to forward that to him, okay?
All right.
Forward that to him right away now.
Mm-hmm.
Vikram Chinnam, right?
Vikram.chinnam@gmail.com.
Do you want it to be sent to you too?
No, it's fine. I don't have an email.
Okay, Ma. I've sent it to him. Just tell him that I've sent, Ma, without fail.
Okay, thank you.
Yeah, Ma. Bye-bye.
Bye, Miss Priya.
Bye, Ma. Yes, Ma.
Can I take my wands?
இப்போ பண்ணுமா உனக்கு?
Yes.
Really? You're feeling much better?
Yeah.
You can do.